Okay, this is P4 January 2022 question 3. As you can see, starts off as a parametric equation, and it looks to me like that second part is going to be partial fractions by the looks of things, but let's make a start. It's going to be a long question. So we're starting off that it says y is equal to 6 over 7 plus cos 2t, x is equal to 3 plus 2 sine t, and it says show that C has the Cartesian equation 12 over 7 minus x, 1 plus x. So what I'm simply going to do is to substitute in the x values in here and in here. It's always a good idea to have a little bit of a plan before you get started. When I do that, I'm going to get sine and sine in those two brackets. That's going to lead to sine squared. Sine squareds and cos 2t are in a trigonometric identity. So yeah, that looks like a good plan to get started. So we begin with y equals 12 over 7 minus x, 1 plus x, and then let's just put in our values. So 12 over 7 minus, just be careful with the x because it's minus 3 minus 2 sine t here. It's often a place where we can just make a silly mistake there. And then 1 plus x is going to be 1 plus 3 plus 2 sine t. Let's just tidy that up in terms of the look of it. Move that over a little bit. Okay, so at this stage, before I do the multiplying, let's just tidy up the constants. 7 minus 3 is 4 minus 2 sine t. And then this is going to be 4 plus 2 sine t. So if I multiply those two things together, it's quite neat. It's a minus b, a plus b here. Okay, so you can multiply it all out taking ages, but I'm recognizing this, P4, you should be able to do things like this, that's a squared minus b squared. So straight away, I'm going to say that's 16 minus 4 sine squared 2t. If you want to multiply it all out and cancel out, you'll have minus 8 sine t plus 8 sine t. By all means, go ahead and do that. I've got no problem with you doing that. But, yeah. Let's go back now and have a look at what I'm trying to get to here and what I've got so far. So I can see that the sine squared 2t is a good bit there. What I want to do then, if I'm going to do this, is to remind myself that cos 2t is equal to lots of things. It's equal to cos squared minus sine squared. It's equal to 2 cos squared minus 1, but it's also equal to 1 minus 2 sine squared, okay? So that's what I'm trying to do, is to get that, just excuse me a second, that should actually be sine squared t. I don't mind making mistakes and leaving them in my videos here. It's something you should spot as you're going through. We don't all do everything perfectly straight away. So yeah, if I've got cos 2t is 1 minus 2 sine squared t, I'm trying to get 1 minus 2 sine squared t out here. So that means I'm going to do something what might look a little bit strange, is that in order to end up with that then, what I really want to have, is 12 over, and I want 1 minus 2 sine squared. So because I've got 4 sine squared in there, the only way to do that is to have that written down like that. Okay? So if I'm going to do that, that's 2 minus 4 sine squared t. I'm now going to get rid of all that thought process there and say, really, I want this to be 2 minus 4 sine squared t. So if I've got 16, I'm going to split that up into 14 plus 2 minus 4 sine squared t. So that looks a bit unusual there, but you know what's coming next because of what I've just done there is now going to be 12 over 14 plus and then I'm going to take 2 out as a factor to leave me 1 minus 2 sine squared t. And why did I do that? Because 1 minus 2 sine squared t, as we can see up here, I can now do that substitution and make it cos 2t. So I'm going to get equals 12 over 14 plus 2 lots of cos 2t. If we then look at the answer and we see they've got 12 over 6 over 7 plus cos 2t. Sorry, it's a circle that I'm looking at there. Yeah, that works out perfectly now, doesn't it? That I can just divide both sides by 2, top and bottom by 2, because this was y equals all the way through, wasn't it? So I get y equals 6 over 7 plus cos 2t, which is what I was trying to prove in the first place. So, yep, that's the answer to part A done. Not particularly easy, but where we go that. And now we've got to look at the second part of it, which is working out what P and Q are going to be. You could have done this at the start, or you could do it, as I'm going to do it, you could do it now. So if I've got that x equals 3 plus 2 sine t, which I have, and they've told me that t is going to be pi over 2, or minus pi over 2, sorry. When t is minus pi over 2, I'm going to get x equals 3 plus 2 sine minus pi over 2, and that's 3 minus 2, so that works out to be equal to 1. Just going to copy that over again here and say the other possibility was to have t being pi over 2. So there we'd get x equals 3 plus 2 sine pi over 2, 90 degrees obviously. That works out to be 3 plus 2 this time. So that works out to be equal to 5. So, getting it the right way around, P is equal to 1 and Q is equal to 5. So that's A completely finished. Okay, so we've proved that part and we've also done the limits there. Okay, on to part B. So part B says, hence find the Cartesian equation in the form a over x plus b plus c over x plus d, where a, b, c and d are constants. So what they're really saying is, can I do partial fractions on that? So we've got y equals 12 over 7 minus x, 1 plus x, and what I want to do with that is change that into, so the same thing again, 7 minus x, 1 plus x, and I want to call that a over 7 minus x plus b over 1 plus x. Really important part of your exam strategy is that you could come and have a go at doing this without having done part A, and you can still get all of these marks. Standard partial fractions. So what I want to do is on this right hand side to make it 7 minus x, 1 plus x as my common denominator. So this thing needs to be times top and bottom by 1 plus x. So I end up with that. And the b parts, this thing needs to be times top and bottom by 7 minus x. So we end up with that. That's all equal, whoops, that's all equal to the first part. And now what I can do is equate the top lines. If I equate the top lines, these two fractions are the same as each other. So I get that 12 equals a 1 plus x plus b 7 minus x. you've done any practice of partial fractions, this should be easy from here, but we're just going through and finish it off. I tend to just get rid of A and then get rid of B. So in order to get rid of A, I want x to be equal to -1, because then that thing will be 1 minus 1, which is 0. So when I choose x equals -1, I get 12 equals A times 0 plus, and just be careful with this, this is B, 7 minus -1, so that's 8B. From that, I get that B is equal to 12 over 8, and 12 over 8 is the same as 3 over 2. Now let's get rid of the B. So I'm going to choose x equals 7 here. That will give me 12 equals A times 8 this time, and nothing times B this time. So A will also work out to be 12 over 8, will also work out to be 3 over 2. Make sure I do my final answer. Just use my iPad to help me. So 12 over 7 minus x, 1 plus x is equal to 3 over 2 here and 3 over 2 there. I'd much rather that you actually then, as a final answer, put this as 3 over 2, 7 minus x plus 3 over 2, 1 plus x. Just looks a little bit more like a standard A-level answer. Okay, hopefully that makes sense for question number 3.